Hey y'all, we are going to review, we're going to review arithmetic sequences. Some of you have already done this. We want to just refresh it since we're kind of math testing. It's been a really weird week. So on this homework 6, arithmetic sequences that's in your packet, I'm going to do all the odd ones with you, and you're going to do all the even ones on your own, and then you'll take pictures and submit. So the first chunk says, determine whether each sequence is an arithmetic sequence. If yes, identify the common difference. So is it an arithmetic sequence? Remember, in order to be an arithmetic sequence, I am either adding or subtracting by the same number every single time. So if I look at number 1, to go from 4 to 7, what am I doing? I'm adding 3. 7 to 9, am I adding 3 again? I'm not, I'm adding 2. So this is plus 3, this is plus 2. Right away, they're not doing the same thing. So is this an arithmetic sequence? No. Number 3, I'm going from 7 to 10. Well, that is plus 3. 10 to 13, is that plus 3? It is. 13 to 16, is that plus 3? It is. So yes, it's an arithmetic sequence. Now I can determine what is the common difference. What is my D value? And my D is a positive 3. Number 5 has some negatives, so be careful here. I'm going from, negative 13 from negative 13 to negative 6. How am I doing that? Looks to me like I'm adding 7. From negative 6 to negative 1, is that adding 7? It is. From 1 to 8, is that adding 7? It is. So yes, this is an arithmetic sequence because I'm adding the same thing every time, and my common difference is 7. Keep in mind, to be an arithmetic sequence, you could be adding or subtracting the same thing every time. All of these ended up being added. Some of them over here might be subtracting. It just depends. But you're adding or subtracting the common difference, the same number for every time. All right, you complete the even ones either now and pause it or later. Find the next 3 terms of each sequence. To go from 3 to 7, what am I doing? I'm adding 4. 7 to 11, am I adding 4? Yep. 11 to 15, am I adding 4? Yes. So now 15 plus 4 is 19. 19 plus 4 is 23. 23 plus 4 is 27. So my common difference here, my D was 7. Not 7. Woo! My D was 4. I wrote 4, said 7. It was 4. I was adding 4 every time, and I got my next 3 terms. All right, number 9. So my first term is negative 13, and my second term is negative 11. So I am adding 2. My third term is negative 9. I'm adding 2. I'm adding 2. If I add another 2, I get negative 5. If I add another 2, I get negative 3. If I add another 2, I get negative 1. Let's keep in mind, my first term is negative 13. So I could make a table out of this, and I could go ahead and use my calculator. If my first term is negative 13, my second term is negative 11. So this is how I'm making my table. That would be an ordered pair. My third term is negative 9. My fourth term is negative 7. So I could use my calculator here later on, and we'll learn about that later as we get through more stuff. All right, you do the even ones either now and pause it or do it later. All right, let's go ahead and write the equation for the nth term of the sequence. Then find a sub 24. I want to find the 24th term, so n is going to be 24. Remember, the formula is an equals d times n minus 1 plus your a1. The 2 important things you need to know here is d, which is your common difference. So I need to replace that with a number. And a1, which is my first term. So I'm going to replace this with a number and this with a number. So my common difference, what's it doing to go from 1 to 3? It's adding 2. 3 to 5, it's adding 2. 5 to 7, it's adding 2. So my D, my common difference, is positive 2. My first term, the very first term of the sequence is 1. So substitute those values where I see. My common difference, my first term. Now keep in mind, to simplify this equation, I need to get rid of parentheses by distributing. 2 times n is 2n. 2 times negative 1 is negative 2, and leave that first term on the end there. Once you distribute and get rid of parentheses, it looks like I might have some like terms right here. And my like terms, negative 2 plus 1 is negative 1. So this is my equation for the sequence. If I want to find the 24th term, that means n is 24. Wherever I see n in the equation, I'll put in 24. So 2 times 24 minus 1. Well, 2 times 24 is what, 48? 48 minus 1 is 47. So a sub 24 equals 47. That means the 24th term equals 47. That's how I would write it as an ordered pair. I'm going to show you really quick how you can double check yourself on your calculator. This equation right here really is just the same as y equals 2x minus 1. An is your y value and n is your x value. So if I go to my Desmos graphing calculator and I put in that equation, and I go to my table, if I type in 24, I want to know the 24th term, I get 47. So I can check on here. You know, I'm not really sure because we kind of just started using this. I'm not really sure if you put in, let me see if I put in, yeah, I guess I can't put in an. I'm going to look into that though, but you can always change it into the y and the x, and you can find it using your table. All right, number 13. Remember, here's your formula, and if you want to write the equation for your formula, you need to know A1 and D, my common difference. What's it doing from negative 4 to negative 9? It looks to me like it's subtracting 5. Negative 9 to negative 14, subtracting 5. Negative 14 to negative 19, subtracting 5. So my common difference is minus 5. My A1, my first term, is negative 4. So substitute them in where they belong. Remember, get rid of parentheses, distribute the negative 5. Negative 5 times n equals negative 5n. Be very careful. Negative 5 times negative 1 is positive 5. And then I have the first term right after that. Do I have any like terms? I do. So an equals negative 5n, and it looks to me like that's plus 1. Remember, this is the same thing as y equals negative 5n plus 1. So really, that's your answer, but I'm going to use this part right here to find the 24th term. And I'm going to go right to my calculator. All right, go to your table. The 24th term, when x is 24, so type it in, I get negative 119. Remember, another way, so that means 24 and negative 119 match up. They would be a point on that graph. Another way to do it would be to plug in n as 24. And then negative 5 times 24 is negative 120. Negative 120 plus 1 is negative 119, which is the same thing I got there. So whether you want to do it out mathematically or do it on your calculator, it's fine either way. All right, I did all the odd ones in this section. You go ahead and do all the even ones, either now or later, your choice. All right, last one I'll do with you, and then you will complete 16 as well as all the other even. Charlie deposited $115 in his savings account. Each week thereafter, he deposits $35 into the account. So he already has $115. All right, so we have to be really careful here because she deposited $115 in her savings account, and each week thereafter, he deposits $35 into the account, right? The formula. Now we have to be very, very careful because our A1, remember your A1 is your first term. So my first term, basically my first week after she deposits the money, how much money is in that account? If I had 115 originally and then he deposited 35, there's $250 in that account. So my A1, sorry, not 250, Lord, 115 plus 115 plus that 35 is 150. So my first term is 150. You've got to be very careful with that. Some people think that your first term is this. Well, no. After the first week, how much money is in there? So I had to add those two. What I already had deposited plus what I deposited after that first week. And then my common difference, well, it tells me they're depositing. That means adding. So I'm adding 35 every week. So in order to write my equation, substitute my D, substitute my first term once I found it, and I can go ahead and distribute. Once I distribute, I need to combine my like terms, so it looks to me like 35n plus 115. And that kind of correlates. That 115 is what is in my account to start with, since that's what we deposited. Okay, so there's my equation. So now that I just be very cautious of this, and I did two like this with you on the note, so be very, very cautious. Remember, deposit you're adding and withdraw you're taking away. Now the second part, once I have my equation, I can use my equation to help me answer this question. How much total money has Charlie deposited after 30 weeks? Well, n is your number of weeks. So 35 times 30 plus 115. I'm actually going to jump to my calculator because that's really high. Let's go put it in our calculator. So remember, this is also y equals 35n plus, or 35x plus 115. So I'm going to type that in. And I'm going to go to my table, since it's in proper slope-intercept form, 30 weeks. After 30 weeks, there is 1,165. Look at this, after 1 week, after 1 week, there's 150, which I found was my first term. So just be really cautious on that. All right, I did all the odds with you. You're doing all the evens yourself, and you're going to take pictures and upload it. Let me know if you have any questions. Email me.